We have a presentation by Ian Putnam from the Northeast Archaeology Research Center, based here in Farmington, Maine, entitled Characterization of Traveler and Kineo Rhyolites and Implications for Human Transport. Ian.
There it is. Well, thank you for having me here. Can everyone hear me in the back? Am I loud enough? I'm audible. So today I'd like to talk to you about these rhyolites, the Kineo and Traveler rhyolites, and the work that I had done as a graduate student at the University of Maine. I'd also like to briefly discuss Phase 3 excavation that took place as part of Northeast Archaeology Research Center in northern Vermont. I believe there's the presence of these Kineo or Traveler rhyolites at this site, and I would like to discuss some of the implications that this site has for human transport. Kineo, Mount Kineo, seen in the background here. It's very prominent, it's very visible. It's located in north-central Maine. Bring up another photo. 700 feet of relief out of Moosehead Lake. Lays right smack dab in the middle, in the center of Moosehead Lake. Very accessible by boat. In the tailless slope, get this laser. In the tailless slope, at the base of this cliff, is a known prehistoric quarry. We know that they utilized this rhyolite and they culturally modified it, and we know that its distribution is widespread across northeast North America, the extent of which, however, is not fully understood. When archaeologists refer to Kineo rhyolite, they're not just referring to this very popular outcrop. They're actually referring to a greater series of outcrops in north-central Maine, known as the Piscataquis volcanic belt. And here we have 5 volcanic centers, each one of them with several rhyolite outcrops that are left over, the remnant pieces of the volcanic centers. Starting in the south with Granny's Cap, Cold Stream, the Mount Kineo Center, the Big Spencer Center, and the Traveler Center, which is just north of Mount Katahdin, right in this area. The importance of this material is that it's found, these artifacts are found in a wide area of northeastern North America. And here we have a hypothesized map of its distribution. And then we know that it's found throughout the archaeological record, at least in Maine. We find it in the Paleo-Indian period all the way to late woodland. The first person to suggest the provenance of this material in publication was Charles Jackson in 1838. And not only was he the state geologist for Maine, but he was a state geologist for Massachusetts and Rhode Island, I believe. So he had managed to become very familiar with Moosehead Lake and Mount Kineo. He investigated it to the point where when he was traveling around New England and happening upon archaeology sites, he could link the material, this rhyolite material found at these sites, to the outcrop of Mount Kineo. So he was really the first person to link the artifacts with the outcrop. In my previous work as a graduate student, I analyzed 27 geologic samples and 6 artifacts. The 27 geologic samples were from the Traveler and Kineo volcanic centers. The artifacts that I analyzed were from the Mikowski Farm site on the Penobscot River in Maine, and the Seabrook Marsh site in coastal New Hampshire. And the techniques included petrographic analysis, that's hand specimen analysis, also the use of a binocular microscope, wavelength dispersive and energy dispersive X-ray fluorescence, which I'll get into in just a moment, the use of a scanning electron microscope, and of course an electron microprobe. All these methods were done with the purpose of characterizing and then discriminating between the Traveler and Kineo rhyolite samples of the greater Piscataquis volcanic belt. Just a quick description and hand specimen. We have a ground mass that is blue-green, blue-gray. We have phenocryst of quartz, feldspar, biotite, mica. We also have a pretty distinct white weathering rind that you can see on some of these samples here. And pretty typical of a rhyolitic rock. That's typical mineralogy. In the Traveler rhyolite samples, we see a similar ground mass color. For many of the samples, similar mineralogy, quartz, feldspar, biotite, mica. However, some of the traveler samples have the presence of pyroxene. So that's one way to differentiate the two samples from one another. Also, we have this white weathering rind, which is typical of rhyolites. Moving on to the geochemistry, I used a Bruker S4 Pioneer XRF, and I want to give a very quick, brief crash course on what X-ray fluorescence is, how it's used. And in this case, we would take a rock sample, we'd crush it into a gravel, and then powder that gravel into a powder. We'd then prepare it into a powder pellet, or we'd fuse it into a glass disc, which would then go into these canisters. And these canisters would hold the sample and then put it in this vacuum here, and go into this box, this mystery box. And here's a diagram of what is inside the box. We have an X-ray tube, which bombards the sample with X-rays. It superheats the sample to the point that it fluoresces, and it emits electrons, energy in the form of electrons, which then get sent through a vacuum and into this energy counter. And this energy counter can pick up energy counts for a number of elements on the periodic table. And these energy counts are translated into kilocounts per second. And the kilocounts per second are then applied to a calibrated standard of known geologic samples. So all these geologic samples have known compositions. The kilocounts are applied to this calibration line, and it allows us to determine the elemental concentration, either in weight percent or parts per million, to understand the geochemistry of the sample that we're analyzing. So for my study, we're using the rhyolites. This method, I should note, is destructive. So with geologic samples, it produces a graph like this. And in this case, I chose zirconium and titanium in weight percent. The reason I chose it is because surfaces that are weathered tend to not affect the composition or the concentrations of titanium, zirconium. They're very stable in the face of weathering. So a weathered rock versus a non-weathered rock will not change the geochemistry that much. One thing I'd like to point out is that we have the kineo samples here in red, plotting separate from the traveler samples here in blue. There is some overlap here with this sample. We have one artifact, a small flake from the Mikowski farm site that we did crush, powder, and prepare for analysis, which plots well within the range of traveler samples. So the benefit to this technique is that we get weight percent concentrations and parts per million concentrations, which then make this study comparable to other studies using different X-ray fluorescence units. So this is a benefit to this technique. The downfall is that it's destructive. So we try to come up with a non-destructive technique that doesn't require the crushing or the powdering of an artifact. In this case, we just ran the whole artifact, preserved. It did not get destroyed in any way. This method is considered standardless because, like the previous method I showed to you, it analyzes kilocounts per second. But those kilocounts per second are not translated into weight percent concentrations or parts per million concentrations. So it makes the analysis only internally comparable, cannot be compared to other analyses from different X-ray fluorescence machines. And here's a non-destructive analysis. You can see it's in counts here, energy counts, and then this is a ratio of counts down here. But again, we see the kineo samples in red, plotting here, traveler samples in blue. There is some overlap between the samples, you can see. However, they do display a similar plotting from the previous destructive method. We have two artifacts from the Mikowski farm site right here, one plotted well within the range of the traveler samples, which is the artifact we saw in the previous plot. One in a more ambiguous region of overlap, and then the Seabrook Marsh site artifacts plotting all well within the range of the kineo samples. One issue with the artifacts that were chosen was the location of the sites. Now, there's two mechanisms of transport that can carry these materials over long distances. The first being glacial distribution. So as the Laurentide ice sheet expanded over the Piscataquis volcanic belt, we have the material is carried down across a big portion of Maine and even parts of southern New England, possibly. This is a hypothetical map, I want to point out. This is not set in stone. But we have Mikowski Farm and the Seabrook Marsh site here in that range of glacial distribution. So, fortunate enough, working for Northeast Archaeology this past summer, we worked at a site in northern Vermont that has what I suspect to be the presence of these rhyolite materials, and we're outside of this range of glacial distribution. The headquarters site, it's in Swanton, Vermont. It's adjacent to the Missisquoi River on Route 78, done as part of working with Vermont Agency of Transportation to mitigate any of the cultural materials that might be disturbed in the expansion of the road. It's a stratified site, a deeply stratified site with occupations potentially as old as the Middle Archaic and continuing throughout the late woodland period. Here's another photo of some of our crew profiling one of our walls. These two blocks that I just showed you contain the presence of this debitage. And here we have some of the Kineo-rhyolite debitage. As you can see, the ground mass matches up with some of my hand samples I previously showed you. And the phenocryst mineralogy, quartz, feldspar, biotite mica. I did not see pyroxene in this, however, it's not to say it's not there. Here we have some tools that we found. And actually, before I go ahead, this debitage here was found in context with early Middle Woodland pottery. So we think that this was found in an early Middle Woodland component. Likewise, this scraper here, found in context with the flakes, so early Middle Woodland. We have a untyped projectile point, maybe someone here knows what it is, found in context with late woodland pottery and a late woodland stratum. And then what appears to be a Levana preform. What I'm not positive about is whether this is a middle woodland or a late woodland tool. I don't know quite, we're not quite sure. We haven't constrained the age of the location where this was found. So the implications, Swanton represents a distal site about 280 kilometers from Mount Kineo, containing Kineo-rhyolite outside the Piscataquis volcanic belt's range of glacial distribution. The rhyolite was likely transported to Swanton through human trade networks. And I also think that non-destructive X-ray fluorescence has the potential, with a little more work, to source culturally modified rhyolites while also preserving them in the process. And I'd like to thank our company directors Ellie Cowie and Bob Bartone for allowing me to be here, and of course Vermont Agency of Transportation. And take any questions if we have the time. Not sure.
Yeah, about 8 minutes.
Oh, great. Yeah.